Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now in that series of 2025 complex numbers P3 questions, this is video number 2. And in this video, the focus will be on trigonometry, modulus argument form, some rules related to multiplication, division, power, some plotting on the ARG diagram. No, loci 1 is different. So 1, 2, 3, 4, and maybe some transformation related issue. Something similar was discussed at the end of video 1. So in the very end, go ahead, watch that so that you have a clear-cut idea exactly what I'm talking about. Now the first question over here, it's May-June 2025, variant 31, question number 3. So let me show you this particular question. That question number 3 we talked about, my bad. Question number 6. So now over here, this is what we are talking about. Let me first add a page so you can comfortably have a look. So now over here, we say that the question is given z1 is 3 and pi by 4, that is the argument, 3 is the modulus. z2, 3 by 2 is the modulus and pi by 6 is the argument, pi by 6 pi, and this is pi by 4 pi. Got it? And then the third one is w, a strange kind of a w, some Greek or Latin symbol. This is 2 and this is pi by 2. Now, first thing that they're asking is that state the values of wz1 and wz2. Give your answers in the form this thing, where r is greater than 0 and theta lies between minus pi and positive pi. Positive pi is inclusive, minus pi is exclusive. So basically over here, maybe they're asking about the magnitude. Only then they can be asking about state the values. And give your answers in the form. So if they want the whole complex number, then you have to do the whole process. Now sometimes I observe that they are very miser on the space. They should be giving a little bit more space. So even I am having difficulty with this. And then the next one, on a sketch of an ARG diagram with origin O, show the points A, B, C and D representing the complex number Z1, Z2, WZ1, WZ2 respectively. State the geometric effects of multiplying Z1 and Z2 by W. So now this is for 2 marks, 1 mark for multiplication by this, 1 mark for multiplication by this. So now this has something to do with transformation. And again, as I emphasized earlier, you have to watch video number 1. So now let's look at the working. First thing first, we know that 3 into 3 over 2, 3 into 2, that is 6, that is WZ1 magnitude. 3 over 2 into 2, that is the magnitude of WZ2. Individual magnitudes multiply, that's a simple rule. Now you write this thing, you write it directly, no one cares about it in this question because the marks are very low. Argument, both the arguments add up. So pi by 4 plus pi by 2, pi by 4 plus pi by 2. That means if the argument was pi by 4, you add pi by 2 over here and it goes like this. Now focus on this because that would be the geometric effect. So that is 6ei 3 pi by 4, and similarly argument of wz2, that's pi by 2 plus pi by 6, that's 2/3 pi, like this. Again written in this form, rei theta. Now the next one, on a sketch of an ARG diagram. Now over here, I need some rough values. So wz1, let me open this up. This is negative 3 into 1.4, approximately this is like 4.2. And this is 3 root 2. So now this green one that is over here, that is something like 4.2. Let me just shift this thing a bit, something like this. So this is 4.2 and then this is like 4.2, something like this. So this is like this and this, something like this. So I have drawn it realistically. WZ2, that is minus 3 over 2 plus 3 root 3 over 2, that is this thing. Then we have the green one is WZ1, the purple one is WZ2. Then we have A and B. So A is over here, B is over here. Again, I have shown the expansion and a rough. These values are exact, but the plotting, that is kind of rough. Now the next thing, state the geometric effect of multiplying Z1 and Z2 by W. Now focus on this. Again, part 1 is related with part C. So part 1 and part C are related. So now the magnitude changes by a factor of 2. That means if I have this thing Z1, the magnitude is how much? The magnitude of Z1 is 3, and magnitude of WZ1, that is I think 6, because this thing is 2. So this is 2 into 3, that is 6. Similarly, magnitude of Z2 is 3 over 2. So magnitude of WZ2, that is 2 times 3 over 2, which is 3. So isn't this magnitude changes by a factor of 2? Can I call it enlargement? Because they're talking about geometric effect, they're talking about transformation. So transformation with a factor of 2. So if this has a magnitude of 3, that's double the magnitude. If this has a magnitude of 3 over 2, that's double the magnitude. So that is the first thing. There are 2 geometric effects. In a later question, they would number it. They state 2 geometric effects. That's the first one. The second one is anti-clockwise rotation by 90 degrees or pi by 2. Why? Because first, the argument was pi by 4. And then when pi by 2 is added, this is pi by 2 added, so therefore it's going that way. So 90 degrees anti-clockwise rotation. The same thing happens with WZ2. So these are the 2 effects that is happening. That is the first one. That is the second one. This is very, very important. Now they are giving this particular touch to it. So now this is question number 6 of May, June 3031. Let me go to May, June 3033. So 1, 2, 3, May, June 3033, question number 6. No, question number 4. Yes, that's the one. Okay, let me add a page. First, have a good look. Now, this is more like symbolic. It says it is given that Z1 is R1 EI theta 1, Z2 is R2 EI theta 2. Show that Z1 into Z2 after multiplication and then taking the conjugate, that's the same thing as the conjugates multiplying together. This is for 3 marks. Next one, Z is this much. It's a root of this equation where B and C are real. State the other root and hence find the values of B and C. So another 3 marks. So this is which variant? That is May, June 3033, question number 4. And this is, of course, 2025. So now this one, let's get started. It's upstairs. That's this one. So first of all, I'll write Z1 has a magnitude of R1. Argument of Z1 has a magnitude of theta 1. Z1 star will still have the same magnitude. So conjugate doesn't change the magnitude. But argument of Z1 will be negative. So the same thing with Z2. So now Z1 into Z2 star magnitude, it's still R1 into R2. Z1 star, Z2 star magnitude, it's still the same. So these 2 magnitudes are exactly the same. These 2 are exactly the same, whether we first multiply, then take conjugate, or take the conjugates and multiply. So that's one thing. What about the arguments? Argument, individual magnitudes add. Now let me take the conjugate of this answer. So therefore there is a minus sign, which is minus of theta 1 plus theta 2. And similarly, when we talk about argument of Z1 star, Z2 star, that is negative theta 1, negative theta 2, isn't this answer exactly the same? So not only are they same magnitude wise, they are also the same angle wise. Perfect. Now over here, this thing, Z1, it has a magnitude of 3. It has an angle of pi by 4. Let me write it out, expand, and this is what I'm getting, Z. That is 3 root 2 plus I, 3 root 2 over 2. And the other one, the other root has to be the same thing but conjugate. So we know that in polynomials, whether we are talking about quadratics or cubics or quartic, complex roots occur as conjugate pairs. That is the thing. Okay, now over here, what are they saying? So now let's use that concept from P1 quadratics, x minus p, x minus q, make it equal to 0, and then you write it out. So this is like p, this is one root, this is the other root. Now the complexity increases because of these surds. So this is z minus this, this is z minus this plus this. This is like a, this is a plus bi, and this is c, this is a, this is b, this is a, this is b. So this is a square plus b square, and then look at the working. And that's how we get it. So initially it looked difficult. In complex numbers, you have to take care of this. There are no shortcuts. Algebra is everywhere. It's in the air. So the next variant that has this thing, which is question number 3, May June 2025, variant 35. So 1, 2, 3, 4, and this is question number 3. That is this one. I think this one was slightly different because the magnitude, that had no issue with that, but the argument was written in radians and like decibels. So this is 5, this is 0.25. Similarly, we have this thing which is the 6, and this is 3, this is 6, and this is 3. So now nothing fancy, nothing difficult except for the looks of it. So S over T modulus, that is S modulus divided by T modulus, write it like this. And what about the theta? The angles subtract. So that's how it's written. Now the same kind of question is being asked as asked earlier. That is, in an Argand diagram with origin O, the points A and B represent the complex numbers such and such. Hold for a second, let me just switch through it. Okay. So now it says, by considering the line segments, so A represents S and B represents S over T. So basically S is becoming S over T, and we are dividing by T. Okay, so dividing by this thing, this is T, this is T. Okay, so one complex number is divided by other. So now what is happening is that this factor of 1/6, because basically 5 is becoming 5 over 6. So 5 is becoming 5 over 6. We are multiplying with 1 over 6 or dividing by 6. So I'll prefer this thing because scale factor is about multiplication. So over here, magnitude is multiplied by a factor of 1/6. That means this is an enlargement. And the scale factor is 1 over 6. That's one thing. What about the argument? Since this time the angle is subtracted, so we know that clockwise angles are negative. So let's say if this angle is pi by 4, and then we are subtracting pi by 2, that means I'll draw pi by 2 over here, and then this thing will be going like this. So this is clockwise. So negative is a clockwise rotation of 3 radians, because that's how the change is. So that completes video number 2, which is very, very important, of 20-25 questions: modulus, argument, geometric effects, something very, very important. Stay tuned for more videos.